This video is a quick review of trig graphs, sine and cosine specifically, and how we're going to use them to solve some application problems. The first thing to be successful with trig functions is to understand what their parent graphs look like. If you don't know what the parent graph looks like, you don't know how to shift it and adjust it to make other graphs. So the sine graph, y equals sine theta, is always going to start at the midline. Okay? And if there's nothing over here, the midline is 0. It's going right along the axis. It goes as up to 1, at the middle it's back to 0, down to -1, and at the end it's back to 0. So I have 3 points, 1, 2, 3, at the same spot before I finish one cycle of that graph. Okay? Start, end, and middle is at midline. Now the cosine function looks a little bit different. Cosine always starts up. In the middle it's all the way to its lowest point, and at the end it's back up again. Okay, it looks like a cup. Cosine looks like a cup. Start and ends up, the middle is the low, and it just looks like y equals cosine theta. If you don't see anything over here being plus or minus, then it's always going to be across the 0. That's where it'll be centered. Okay? So once you're comfortable with the parent graphs, which you should definitely write down and look at and familiarize yourself with, the curves, then we can start talking about changes to the parent graph, which is what all of your problems and applications are going to be. So in this equation, you can see what each part of the graph does to the graph. So if there's a number in front of the sign, that affects the amplitude, which is the vertical stretch. Not necessarily picking it up and moving it up and down. It stays centered in the center, but it becomes taller and longer in above and below. Okay? That's amplitude. The period is affected by B. If there's a number in front of the theta, between sine and theta, or cosine and theta, then that's going to affect the period. But it's not the period by itself. The period will always be 2 pi divided by that number. Okay? So that will tell you how long you get for one cycle. So if there's no number here, then the normal cycle is 2 pi. That's the standard. But if there's a number here, it means it's going to change that cycle by doing 2 pi divided by b. Now, this last number on the end is going to affect the actual vertical shift. And we had this before in other graphs. If my midline was here, when I get a +5, it means my entire graph, including the midline, moves up 5. Everything that was down here gets moved up 5 spaces. So it's a vertical shift, not the same as a vertical stretch. Okay? So it's can be either up or down, depending on whether it's positive or negative. And it affects that midline. So make sure you have that written down and you understand what each portion of that equation is going to do to the graph. Let's look at some equations. So without actually graphing them, we're just going to look at their features and see what we can tell about them. Okay? This negative sign in front, which we haven't talked about, means to flip it upside down. So if the regular cosine graph looks like this, the inverse, or a cosine graph with a negative in front of it, is going to look like this. Okay? Because it's been flipped upside down. So I can tell the amplitude is 4. The amplitude is not -4. The negative sign flips it, but the amplitude is the number, the absolute value, in front of the graph. Take a look here. Okay? The period is going to be 2 pi divided by 1/3. So you're going to have to get used to thinking about that, flipping a fraction. 2 pi divided by 1/3 is the same as 2 pi times 3, so the period is 6 pi. And that means it's going to take 6 pi for me to finish one full cycle of that cosine graph. So it's sort of stretched out. Instead of 2 pi, it takes 3 times more space to do one cycle. And this +1 means my midline has moved up 1. So I have a graph that has moved up 1, and then it's 4 times steeper, and its period is stretched out. Okay? Second one, what's the amplitude? Amplitude is the easiest because you can just look at it and see it. What's the period? Remember, the period is not 3. The period is 2 pi divided by 3. So this would be my period. And then -4 means my midline and my entire graph has moved down 4 spaces. And then the last one, what's the amplitude? What's the midline? And what's the period? Not 6. 2 pi divided by 6, or pi over 3, because we simplify fractions. So step 1 when you're looking at these graphs is to say what's going on in the equation that is changing it from its normal parent graph shape. Okay, well now we're going to try to graph one. Here we have 6 cosine 2 theta plus 2. What I usually do first is I look at the midline. Aha. So instead of making my graph go across at 0, I make a little dotted line here at 2, because this tells me that that's now the middle of my graph is 2. So then I look at the amplitude. The amplitude means it's going to be 6 above and 6 below. Okay? So if I go to 2 and I go up 6, now I'm at 8. And I go down 6, I'm at negative 4. Okay? Because the midline is the center of my graph, and this 6 tells me it's 6 above and 6 below the center. So I have these spots in place. And it's cosine, so I'm putting my 8 at the top and I'm putting my negative 4 at the bottom. And then this 2 theta means I'm going to take the period by saying 2 pi divided by 2 equals 1 pi. So here's 1 pi. I have to finish one full cycle of that cosine in that 1 pi. So I start up, swoop it down, and swoop it back up. I'm done with 1. And I could keep going. Start up, swoop it down, bring it back up for a 2nd pi. Start up, swoop it down, bring it back up for 3 pi. Okay? Because these graphs repeat over and over and over. They're cycles. Second equation. 3 sine 1/2 theta minus 1. First thing I always look at is I look for that midline. So I drew a dotted line at negative 1 to show me, you know what, that's going to be my center line instead of 0. Then I notice it says 3. So instead of going up 1 and down 1 from my midline, I'm going to go up 3. 1, 2, 3, up to 2. And down 3, 1, 2, 3, down to negative 4. Okay, so now I have my high point and my low point. And next, I have to look at my period, 1/2. So I do 2 pi divided by 1/2, which is the same as 2 pi times 2, or 4 pi. That means I have all the way to 4 pi to finish the equation, or the graph of this equation. So halfway, remember with the sign, it's on the midline at the beginning, it's on the midline halfway, and it's on the midline at the end. So I make those spots. And then I'm going to gradually just curve up, back to the middle, curve down, back to the middle. That's the graph of this equation. So, like one that we did in class today, we discussed, what about a Ferris wheel? Okay? If we were given the equation that said y equals 65 sine 2 pi over 5 theta plus 75. Wow, that's a mouthful. But that's okay, we're going to do the same thing. First thing I look at my midline. That means that my graph is actually going to be, in the middle of it is 75 instead of 0. So I'm going, boom, right up here to 75. The amplitude is 65. That means from 75, it's going to go plus 65 and minus 65 to get my highest part of the Ferris wheel and my lowest part of the Ferris wheel. Okay? The amplitude is, funny enough, is also the radius of that Ferris wheel, if you think about it. If you think about, we're in the middle of the Ferris wheel and there's a big circle, 65 up is the top of it and 65 down is the bottom of it, that means that must be a radius. Okay? So far so good. We know our highest point then is 75 plus 65. And our lowest point is when we first get on the Ferris wheel is 75 minus 65, or 10. Okay? Now the last thing we have to figure out is what's the period of this Ferris wheel. So I take 2 pi and I divide it by 2 pi over 5. I don't get worried that it already has a 2 pi in it. I don't care. My rule is I take 2 pi and divide it by whatever this whole number is. Okay? But dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to say 2 pi times 5 over 2 pi. So 2 pi on top, 2 pi on bottom cancels, and I just have 5 over 1. 5. So the period, or the time it takes that Ferris wheel to go all the way around one time, is 5 minutes. That's what we've just found out. You know how slow Ferris wheels are. So if I needed to graph this, it would look something like this. Going to be kind of small. I'm going to make, let's call this 0, and let's call this 75 feet. Okay, that's my midline. And I'm going to go up here to 140. We already decided that was our top. And I'm going to come down here to 10. That was our bottom. And it takes 5 minutes, so I'll go 1, 2, 3, 4, 5. Okay, now they gave me sine. If you remember, sine starts at midline, and in the middle of it, it's midline, and at the end, it's midline. The end of that 5 minutes. Okay. And so that means in halfway here I have to go up to 140, and halfway over here I have to get down to 10. Here is the graph of one cycle of that Ferris wheel. I could do another one and do the same thing, mark the same points. 1, 2, 3, 4, 5. And I would go up again and down halfway and back again, because it will go over as many times as the Ferris wheel goes around. So this is how we're going to use these equations to find things like the highest point and the lowest point and how long it takes to get around. Okay? You'll have additional practice with this, but make sure that you understand this and bring questions to class.